Guys, here for part two of your final exam review. This one on quadratics and polynomials. So we'll dive right in. So the first section is just about the number of solutions that a quadratic could have. So for that, all we're looking for is how many times we cross over the x-axis. So this one says the quadratic has one solution. Clearly false. We don't cross through the x-axis, so that's going to be not true. Next one says no solution. And we can see we go down and hit it in one spot. So it should have one solution. And this number three is going to be true because this says that we have two solutions and we have two x-intercepts. So in general, if we're asked to summarize this, I would say that the number of x-intercepts correlates to the number of real solutions that you have. So directly correlates to that. So that would be your answer there. The next group is going to be about discriminants, using the discriminant. So I've actually already worked this out, but you guys should be able to work it out by hand as well. So of course, you could always graph these functions using Desmos to figure out how many solutions something has. But what they really want you to do is use just the b squared minus 4ac part. So what I did was I worked out all three of these. So you can see the a, b, and c values of all of them. 1, -4, -32, 1, -8, 16, and 1, -4 and 25. So I worked out each one of those with b squared minus 4ac. So here's 1. -4 squared minus 4 times 1 times -32. We get positive 144, which our solution for that means that we're going to have two solutions. If the discriminant is positive, we're always going to have two. The second example, -8 squared minus 4 times 1 times 16. We're going to end up with 64 minus 64, which is 0. And 0 is going to mean that we have one solution. And lastly, number 3, -4 squared minus 4 times 1 times 25. That would give us -84 as our discriminant. And then, of course, a negative discriminant means that we have no real solutions. In case you wanted to do this on Calculator Soup, the Calculator Soup will do the discriminant for you. You need to put in your a, b, and c values. So you can see I already have 1, -4, and 25 in for the third example. And then as you scroll down, right before you get to the end, you can see they've got that square root of -84. That is your discriminant right there. And they give you a little blurb afterwards. The discriminant is less than 0. So there are, in fact, two complex roots. So to explain in detail how to determine the number of solutions a quadratic function will have, if the discriminant is positive, you'll have two solutions. If the discriminant is 0, you'll have one. And if the discriminant is negative, you'll have no real solutions. So moving onward, we're going to go on to polynomials. So it says the name of the polynomial on the left is a quartic, and the name of the polynomial on the right is a cubic. If false, correct the statement. It is false. They've got that backwards. This guy is a cubic right here, and this guy is a quartic right here. So we can tell that from a number of things, and we'll kind of elaborate on all of those things. So that would be end behavior. Like this one starts low and ends high. Okay, this one starts low, ends low. And starting and ending on opposite side would mean that you would be an odd function. Starting and ending on the same side of the x-axis, that would mean that you're an even function. Okay, so clearly cubics are odd functions, so that's this guy right here, and quartics are evens. Number of zeros, it's always going to be the case, like this cubic has degree 3. So then you can see this has 3 zeros, which would mean that it has to have at least degree 3. Mins and maxes, it's always going to be at least one less than the degree. You can see this guy right here has one maximum and one local minimum. So that's one less than degree 3. The degree of the function, if you actually have the function, you can see that, raised to the third power to the fourth. And leading coefficient is just going to tell you which direction that it goes. So they did say about the shape of the polynomial, so I thought that should be included as well. So this polynomial has an odd degree. That's false. This is even. You can see the end behavior. We start low and end low. And because we start and end on the same side, this function, then it's going to have an even degree. So what degree tells you about a polynomial? Just end behavior. So if it's got an even degree, we start and end on the same spot, either start low, end low, or start high, end high, like if this graph was flipped upside down. And also, odd functions would be, odd functions are going to start low, end high, like our cubic right here, or be the opposite way around and start high and end low. Okay, so in terms of having a negative leading coefficient, this is true. This graph is upside down. There's a couple ways that you can figure this out. You can look back through the toolkit notes, or you can just make, this is a quartic function. I just went into Desmos and made a quartic function. And pretty clearly this is facing the opposite way. Okay, so then what I would do to make it face that way, I could put a negative in, put a negative in front. And you can see now we're starting low, ending low. So that would imply that this one's just alike, that it has a negative value in front, negative leading coefficient. And the sign of the leading coefficient just tells you if it's going to open up or open down. So this function has an even degree or power, once again false, and that would be because this graph starts low and ends high, so that's got to be odd, more than likely a cubic function, but it could be a 5th or 7th degree function as well. So what the power tells you about a polynomial, so the power is going to tell you, once again, the end behavior in the general shape. So this polynomial can have a maximum of 4 zeros. I don't love this question, but it is true. This is a, right here, this is a quartic function. So this particular polynomial itself only has 3 zeros. But generally speaking, quartics, like if we came up here and then came back down, we could have 4 zeros. So in terms of number 18, the maximum number of zeros possible, it's always the same as the degree. Okay, so, and then I know I mentioned this earlier, but I'll just hit it again. This is a cubic function. The one that we're looking at has 2 mins and maxes, and that's all that's possible. So it's always going to be 1 less than the degree. Cubic polynomial has degree 2, so that would mean that the most possible it can have is 3. So we'll say false. And then you can take a look in, once again, it's right here. The maximum number of local mins and maxes is always going to be 1 less than the degree. So that covers your review. If you want a little bit more elaboration on any of this, please feel free to ask. And good luck on your final exams.